sixth graders. We are on our greatest common factor lesson, still in Unit 3A, our rational numbers unit. Our learning target is being able to find the greatest common factor of two or more numbers. So we know what factors are, and we know what multiples are because we've talked about factors and we talked about multiples. Remember, like 2 and 3 are factors of 6 because 2 times 3 is 6. And then the multiples of 2 would be like 2, 4, 6, 8, 10, 12, and so on. So you might want to write these words down with examples just to remind yourself. So and then remember we talked about the prime factorization. And if we look at the factors, so if we look right here, the factors of 12 and the factors of 18, we can see that we know that the prime factors of 12 are 2, 2, and 3. And the prime factors of 18 are 2, 3, and 3. And we can see that they each have a 2 and a 3 in common. So 2 times 3 is 6. So that means that they have a 6 as a common factor, and that would be their greatest common factor, which would be the GCF. A Venn diagram, which you've probably seen before, is overlapping circles to show how common elements among sets of numbers are related. So this is an example of a Venn diagram. Okay, so we'll talk more about GCF on this page. So there's 3 different ways to find GCF. I'm adding one method here. So I want you to make sure you have an example of each method in your notebook. So let's start with finding the greatest common factor of 18 and 48. Greatest common factor, also known as GCF. So we'll say GCF probably a lot more often than greatest common factor. So one of the methods you can use to find the greatest common factor of 18 and 48 is just to list out all the factors and then find the greatest one. So if we have 18, I know that 1 and 18, so 1 and the number itself are always going to be factors. So I always start with like 1 and 18. And I usually leave a pretty big gap so that I can get all the other factors in there. And then I know that 2 and 9 are factors. And I know that 3 and 6 are factors. 4 and 5 are right in the middle here, and they're not factors of 18. So then I know that I'm done. For 48, I know that 1 and 48, it's even, so I know that 2 and 24 are factors. I know that 3 and can 48 be divided by 3? Let's check it out. 3 goes into 4 1 times 3 is 3, 1. 3 goes into 18 6 times, so 6. So 3 and 16. So if you're curious if a number can go into something, do it like how I did it right here so you can check to see, because you want to make sure you get all the factors. And then I know that 4 and 12, I'm going to run out of room. And then it doesn't end in a 0 or 5, so I know 5 isn't a factor. I know that 48 can be divided by 6, so it's going to be 6 and 8. And then in between 6 and 8 is 7, and I know 7 times 7 is 49, so then those are all my factors. So now my next step is to look at all of my factors, and I can see that they have 1s in common, 2s in common, 3. They each have a 6. They don't have a 9. They don't have an 18 in common, so 6 is going to be my greatest common factor. And then I always check to make sure, can 18 divided by 6? Yep. 48 can be divided by 6. Yep, that makes sense. Okay, if we use the prime factorization method, I'm going to prime factorize out each number. So 18 is 3 and 6. 3 is prime, so I circle it. 2 and 3, they're both prime. And then for 48, I can do 6 times 8. This is 2 and 3. This is 2 and 4. And this is 2 and 2. So the way that I do this is I look at all of my primes. Let's do green here. And I can see that 18 has a 2, a 3, and a 3. And I can see that 48 has a 2, a 3, a 2, a 2, and a 2. So the way that I do this is I find a number that they both have in common. So they both have a 2. So I'm just going to cross off and pull out a 2. So I'm going to write that, I'm just going to write that right over here. And then I can see they both have a 3. So I'm going to pull out 1, 3. And then they don't, this one has a 3, 18 has a 3, 48 only has 2 2's left. So then it's going to be 2 times 3 because they each have a 2, they each have a 3, multiply it, and I get 6. So we have 6 here, 6 here. I'm going to erase this. And then my last one, I'm going to erase just this part right here so you can see, and I knew that would get a little cramped there, is called the cake method, which I think is kind of an interesting way to do it as well. So if I have 18 and 48, I'm going to think of a number that they can both be divided by. So I know they both can be divided by, let's do 2. So 18 divided by 2 is 9. 48 divided by 2 is 24. And then I have to think of another number that they can both be divided by, which they can both be divided by 3. 9 divided by 3 is 3. 24 divided by 3 is 8. And then I look, is there a number that both 3 and 8 can be divided by? Nope, they're done. So then my GCF, I look here at the numbers I multiplied or divided by. 2 times 3, and I get 6. All right, so let's look at these 3 down here. We'll do these together because that's kind of, unless if you want to pause and try each method, feel free, but let's do a few more together. So for 8 and 10, let's list out the factors. So I know 8 is 1 and 8, 2 and 4, and then I'm done. For 10, I know it's 1 and 10, 2 and 5, and then I'm done with that. So I can look quick at my common factors, and I see that they both have a 2, so the GCF is going to be 2. For 6 and 12, let's do the prime factorization. So for 6 is 2 and 3, and then for 12 is 2 and 6, and then 2 and 3. So then I can see that they each have a 2, so I'm going to pull out a 2. They each have a 3, so I'm going to pull out a 3, and then that's it. So then the GCF would be 6. Notice that the GCF is one of the numbers, and that's okay. So if I have 6 and 12, and I know that 6 is a factor of 12, then my GCF is going to be the 6. I know it's not going to be greater than 6 because factors are less than the number. So I know my greatest common factor is going to be 6 or less. But if I know that 6 is a factor, I don't really even have to do anything. I just know that, yep, it's going to be 6. And then if I have 10 and 17, I know that 17 is a prime number. It can only be divided by 17 and 1. And it can't be divided by 10. And I know that 1, 2, 5, and 10 are factors of 10. So the GCF for this one, because 17 is prime, is just going to be 1. All sets of numbers will have a common factor of 1. Sometimes that's just the highest because they don't have any other factors in common. All right, so the way that we find the greatest common factor of three numbers is the same. We just take our numbers, list out our factors. So 1 and 12, 2 and 6, 3 and 4. And then 34 is 1, 34, 2, 17. And then 60 would be 1, 60, 2, 30, 3, 20, 4, 15. My gosh, I'm going to run out of room. 5, 12, 6, 10. But because 12 is our lowest number, I know that my greatest common factor has to be 12 or less. So that means all of these are out. They don't have a 12. It looks like the common factor that they all have is a 2. So then my greatest common factor would be 2. For 30, 45, and 75, I'm just going to do my factor tree. So 30 would be 2 and 15, and then 3 and 5. So that'd be 2 times 3 times 5. 45 would be 5 and 9. That'd be 3 and 3. So 3 times 3 times 5. And then 75 would be 5 times 15, I believe. 15, 30, 45, 60, 75. And then that's 3 and 5. So 3 times 3 times, 3 times 5 times 5. So I can see that they each have a, I can see that they each have a 3. I can see that they each have a 5. So it'd be 3 times 5 equals 15. And then the greatest common factor of 42, 70, and 80. So I could do 42, 70, and not 80, 84. I know they can both be divided by 2, which is 21, 35, 42. I know they can both be divided by 7, which is 3, 5, 6, and then that's it. So then my greatest common factor is going to be 2 times 7, which is 14. And then one last real world problem. So the Irish cheerleaders are making spirit ribbons for upcoming Spirit Week. Blue ribbons come in 24-inch spool. Green ribbons come in a 30-inch spool, and gold ribbons come in a 36-inch. They want to cut strips of equal length and use the entire spool of each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool? So meaning they want to cut all the same lengths of ribbons, but they don't want any leftover ribbon. So basically we need to find the greatest common factor of 24, 30, and 36. So if I take 24, 30, 36, and I know that they can all be divided by 2. So 24 divided by 2 is 12, 30 divided by 2 is 15, and 36 divided by 2 is 18. I know they can both be divided by 3, so then I have 4, 5, and 6, and they all can't be divided by anything further of the same number. So my GCF is going to be 2 times 3, which is 6. So that tells me that it's going to be, the ribbons are going to each be 6 inches. So they'll cut 6 inches of each ribbon. And then it says how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces. So if my blue spool is 24 inches and I divide it into 6-inch pieces, I know that that's going to get 4 pieces. My green is 30 inches divided by 6, so that's going to give me 5 pieces. And then my, what's the last one? Gold is 36, and I divide that by 6. So then that's going to be 6 pieces. So we decided that they're all going to be 6-inch pieces of ribbons, and I divide them each by 6. So that's how I get my 4, 5, and 6. And then the question is, how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces? So 4 plus 5 plus 6, so 9 plus 6. So we have 15 ribbons total. All right, that's all I have for you for GCF. Make sure you have some good notes to bring to class tomorrow with all of this good, important stuff, and I will see you tomorrow.